All right. Today we're going to focus on mutually exclusive events. In probability, as we get further and further into it, you guys are going to hear me give different strategies that will hopefully help you be able to understand the question, visualize it, and then find the answer. And one of the ways we do that is with Venn diagrams. So today we're going to be looking at Venn diagrams to help us visualize some different situations with events. And then we'll eventually get to use two-way tables, tree diagrams. I feel like I'm missing one, but that's all my brain can think of right now. I swear there's another one. I'm just spacing it. But so we're going to focus with Venn diagrams today. So anytime you draw a Venn diagram for probability, you need to put it in a box. And the box represents our sample space. So we label it with an S. Now, something you need to keep in mind, the sample space shows all the possible outcomes. So for these pictures, I'm not going to put actual probabilities in there. I'm just going to use them as visuals. But when we start putting actual probabilities in there, you should double check that the total is 1 exactly. It shouldn't be less than 1. It shouldn't be greater than 1. If it is less or greater than 1, then you made a mistake. S should always add to 1 because it gives all the different possible outcomes. And so for it to be legitimate or correct, it should add to 1. So last time we talked about the complement rule. So the probability of A complement or A not happening is 1 minus the probability of A. So if we have event A in our sample space, inside that circle is the probability that A happens. And that means outside it is the probability that A does not happen, or A complement. So A complement would be everything outside the circle. Because in the circle means A is happening. Today, our focus is going to be mutually exclusive events. And mutually exclusive, we're going to define it on the next page in a minute, but mutually exclusive means that they don't happen at the same time. So we have our sample space, and we have A, and we have B. So in this picture, A could happen, B could happen, or outside the circles, neither A or B is happening. Okay, so mutually exclusive means they don't occur at the same time. So there are two types of questions we're going to focus on today for mutually exclusive questions. Finding the probability that A and B happens when they're mutually exclusive. By the way, ME is my way of abbreviating mutually exclusive. And then A or B for mutually exclusive. So A and B before I talk about it. So here's our mutually exclusive events, A and B. So mathematicians, I'm pretty sure I've said it to you guys, they're inherently lazy, and writing out the word and takes too much work. So there is an alternate notation for this, and it's A and B. It's like a upside down U. I suppose you could think of it as an N, and actually that's how I remember it means and, because it looks like N in the middle of and. And what that means is that when we're asked to find A and B, we're looking for their intersection. So when we have mutually exclusive events, there is no intersection, and so the probability of A and B happening is 0, because if they're mutually exclusive, they're never going to happen together, so there's never going to be an intersection. Now, or is a weird word. There's two different meanings for or. Let's say you go out to eat and you order a hamburger, and they say, do you want French fries or a salad? What would you say, Bailey? French fries or a salad?
French fries.
French fries. Joanna, what would you say?
Salad.
Salad. What about you, Nate? French fries or a salad? On the side of a hamburger. French fries. French fires. Yes. French fries. Oh, goodness. Okay. So let me ask you this question. Now I know this is probably highly unlikely, but there might be one of you in this group. If you went to Starbucks and you ordered just black coffee, and the barista says, do you want coffee or cream? What would you say, Emma?
Wait, what were my two options?
Cream or sugar? I said coffee or cream, but I meant cream or sugar.
Cream, probably.
Okay, Piper, what would you say?
Cream.
Okay, Jad. Dun, dun, dun. Cream or sugar? Cream or sugar? No? Nevaeh, cream or sugar?
Cream.
Cream. Isla, cream or sugar? She said cream. Okay, Alexis, cream or sugar? Bum, bum, bum. All right, Chloe, have I called on you? Cream or sugar?
Cream.
Shahar, I know you'll have to type it to me, but would you take cream or sugar? Shahar is typing cream. Really? Really? Okay. Well,
Well, I think honestly I would pick both.
Are you allowed to pick both?
Yeah.
Okay, so why can't you pick both with French fries or a salad?
No, I wouldn't pick both with French fries or a salad.
You're not allowed to
Yeah.
without paying extra. But when the barista says cream or sugar, you can get both.
You say both.
Yeah. So why does it mean one thing at one place and one thing at another place? Because English sucks and our language is weird. So, or is one of those weird things where we can mean we want A only, or we want B only, or we want both. Now with mutually exclusive, we just talked about they're not going to happen at the same time, so that both idea is off the table for today. Tomorrow, it'll be back on the table. So if we're looking at the probability of A or B, here's A. Whoa, my lights just turned themselves on and it is super bright in my room. That was really weird. Here's B. So like I said, with mutually exclusive, the both, having both cream and sugar is not a possibility. So today we're focusing on you can have a salad or you can have French fries, but you can't have both. Tomorrow we'll talk about cream or sugar, where we can have cream only, sugar only, or we can have both. Now, so when we're talking about probability of A or B, we can have the probability of A only or the probability of B only. So we're looking at those two. Of course, because we have an alternate notation for the word and, we have to have alternate notation for the word or, because apparently that's too hard for math people to write two letters. So it's the upside down one. It's a U, which actually makes sense because it stands for union. So when you put things together, union. But you gotta love English, where at one restaurant the or means one or the other, and at another restaurant it means one or the other or both. Are you guys okay if I flip to the next page? Didn't mean to throw it across there. All right, so like I said, we're going to define mutually exclusive, so we have the actual definition, although I'm pretty sure you guys have figured it out at this point. So two events, we're going to call them A and B. Surprise, surprise, because all my pictures had A and B. Are mutually exclusive or disjoint. Sorry, I'm going to take a little tangent here. I will say mutually exclusive. Any homework I write will say mutually exclusive. The test will say mutually exclusive. But let's say, I don't know, in college you take a statistics class, and because you took this one, you're not in the very basic stats class, and they say disjoint events, that is mutually exclusive. My lights are just on and off, on and off. Sorry, it's messing with the brightness here. But so just know disjoint means mutually exclusive, but I don't use that terminology. So A and B are mutually exclusive if they have no outcomes in common. Casper, the friendly ghost, is playing with my lights today. I might just have to go turn them off so it stops doing this. So if A and B have no outcomes in common, they can never happen together. And if they can never happen together, the probability of A and B is 0, because and means intersection, when they occur together. And if they're mutually exclusive, they never occur together. And I'm going to have a few examples of mutually exclusive events, so hopefully it's not so abstract. In other words, two events are mutually exclusive. It is impossible for them to occur at the same time. Now, my first example is, sorry, I gotta turn the lights off. My first example deals with a deck of cards. And I know we talked about a deck of cards last time, but I'm going to go through what's in a deck of cards just one more time in case somebody missed last time. Your homework questions will refer to deck of cards, so that's part of why I want to make sure that we talk about it, so that hopefully I clarify anything before you try to do your homework. So first of all, standard regular deck. That means no jokers. So we don't use jokers. No jokers. Which just makes the game unfun. No, I'm joking. It's like, sorry, I love the show Friends. And when the girls learn to play poker and Phoebe goes, Joker's poker, but with a J. I love that episode. Anyways, sorry. So no jokers. We don't use jokers unless it specifically says it. I mean, sometimes it's fun to add jokers in there to mess with the probability, but for anytime you see standard regular, no jokers. There are 52 cards total. There are 4 suits. Why did I put a C in suits? That was a weird misspelling. So there's hearts. There's diamonds. There's spades. And then there's clubs. And hearts and diamonds, I'm sure you guys know what those look like, but there's a club. That's a club. And that's a spade. My picture's semi-okay, but really not that okay. So spades, clubs. And then each suit has 13 cards. You have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have jack, queen, and king. And jack, queen, and king are what are known as face cards because they have faces. Now, if you're playing with some fancy, I don't know, Harry Potter deck, they might not put faces on them, but so see, here we have a king, a queen, and a jack, and they all have faces. So when it says face card, that's what it's referring to. Aces are not faces. Even though I have kids that go, well, it's a letter instead of a number, it doesn't make it a face card. Okay, there is no face on the ace. So it's not a face card. And then, I almost forgot, we have 2 colors, red and black. Face cards. So hearts are red. Diamonds are red. Spades are black. Clubs are black. And because 2 suits are red and 2 suits are black, that means our 52 cards are split in half between red and black. So we have 26 red and 26 black. And I think that's everything that you need to know about a deck of cards. Like I said, for those of you that know a deck of cards, sorry, I was redundant. But I'm always amazed every year how many kids don't really know what's in a deck of cards. So back to my example, because it had to do with cards. So we're going to pick one card from a standard regular deck of cards. We're going to define our 2 events. Event K, the card is a king. Event Q, the card is a queen. So biggest thing you need to pay attention to here is that we are picking one card only. So what is the probability that the card is a king and a queen? Can a single card be a king and a queen at the same time? No. So in this case, the probability of a king and a queen is equal to 0 because king and queen are mutually exclusive events. They can't happen at the same time. Now, even though they're mutually exclusive, we can find the probability that the card is a king or a queen. So that means, what's the probability that the one card I pick is a king? What's the probability that it's a queen? Because I can have the king or I can have the queen. So what is the probability that if I pick one card, I get a king? Anybody want to venture to guess?
4 out of 52.
Thanks, Chloe. The probability that I pick a king is 4 out of 52. There are 4 suits. Each suit has a king. So there's the king of hearts, king of diamonds, king of spades, king of clubs. So the probability that I pick a king is 4 out of 52. Or my card could be a queen. So what's the probability I pick a queen?
4 out of 52.
4 out of 52, because I have a queen of hearts, queen of diamonds, queen of spades, and a queen of clubs. So what's the probability that my card is either a king or a queen? Well, it would be 4 out of 52 plus 4 out of 52, or 8 out of 52. Now, Nate threw into the chat a decimal, and like I've said before, a decimal is totally fine. I lost my train of thought. It's been happening to me a lot today. The biggest thing, like here, fractions aren't necessarily a bad thing because we know it's exactly out of 52. But like I said, you can use decimals. Make sure you go to 3 decimal points and that you round accordingly. I know you threw it in the chat, Nate, but I wanted to explain why it's 1.54. So just make sure you go to the 3rd decimal, check the number behind it. If it's greater than 5, you're going to round it up. So like Nate put in the chat, it's 0.154. So that brings us to probability rule number 2, the addition rule for mutually exclusive events. So the probability of A or B can be found by taking the probability of A plus the probability of B. And just to hopefully maybe ingrain it in your head, the alternative notation. I don't mind writing out the word, but you guys do need to know them. I will throw those in there sometimes. Are you guys okay if I move it up? Okay. All right. Everyone knows that soccer tends to be a low-scoring game, usually. If you didn't know, I'm a huge soccer player. I've played, this is probably the first year I haven't played in a long time. I was playing last year. Probably the last time I didn't play was when I was pregnant with my youngest. So I've been playing. This is gonna make me sound really old, but I'm not that old. I've been playing soccer for approximately 28 years. And usually it's pretty low scoring. But there was this one game in high school where we won by 16 goals. Our coach told us to stop scoring, and we didn't mean to score, and we kept scoring. I'm not a goalie. My coach put me in as goalie because, well, that's what you do. And I scored as the goalie. That's how bad they were. Emma, you were a goalie? Right. Are you going to print me one?
I don't want to, I just print mine out. I'll print you out one, but do you see what we do for this? What is this?
I don't know, but I'm teaching class.
Here you go.
Thank you.
Tell your students I was the best goalie, though, of all time.
My husband was the best goalie of all time. He still holds records at Linfield College up in Portland somewhere. He's a good goalie. Anyways, but the whole point was we won by a huge amount of goals. We didn't mean to win. I was like playing goalie, and goalies can use their hands, but I suck so bad at it that I, like, when the ball came to me, I used my feet because that's what I was used to. And I kicked it, and it went over a bunch of the girls' heads, and then it just rolled into their goal. Like, I did not try to score, and it happened. Anyways, back to low-scoring games. Soccer, that's the biggest complaint that people tell me when I say I like soccer and I like to watch it. They're like, but it's so boring. Nobody scores. That happens. Sometimes nobody scores. All right. So, what I want you to note here is that we're going to focus on the number of goals scored by one of the two teams playing. Okay, we're not looking at the two teams together, just one. Event A is no goals are scored. Event B is one goal, exactly one goal is scored. Event C is exactly 2 goals are scored. So the probability of event A is 10%, event B is 20%, and event C is 15%. So what is the probability of A and B? So what is the probability? Thanks, Emma. Sorry, thanks, Nate. Sorry, Chloe put something in the chat and it made me laugh. So the probability that no goals are scored and exactly 1 goal is scored is 0, because you can't have no goal scored and 1 goal scored at the same time. So they are mutually exclusive. Here's event A, no goals. Here's event B, 1 goal. they can't happen at the same time, they don't have an intersection, so the probability of A and B is 0. Probability of A or B, so that the team scores no goals or they score 1 goal. We would use our addition rule for mutually exclusive events, and we would add the probability of A plus the probability of B. So again, here's A, here's B. So the probability that A happens is in here, and that is 0.1 or 10%. Probability B happens is in here. By the way, my circles are not to scale. And that would be 0.2 happening. So the probability that A happens or B happens would be 0.1 plus 0.2, or 0.3. And then the last one, the probability of A or C, so no goals are scored or they scored 2 goals. What would be the probability on that one for us? Somebody didn't want to answer. They said peace out and leave in class instead. Is that how it works? So the probability of A still 0.1, probability of C 0.15. So the probability of A or C would be 0.1 plus 0.15. Any questions before I go to our last page? Okay. So on this example, we're going to choose an American adult at random, and we're going to define our 2 events. A, the person has a cholesterol level of 240 milligrams per deciliter of blood or above, also known as high cholesterol. And event B, the person has a cholesterol level of 200 to 239 milligrams per deciliter of blood, also known as borderline high cholesterol. According to the American Heart Association, the probability of A is 0.16 and the probability of B is 0.29. So, explain why events A and B are mutually exclusive. Anybody want to try explaining why they're mutual? Thanks, Nate. Nate said you cannot have 2 different cholesterol levels at the same time. Perfect, Nate. We can't have high cholesterol and borderline high cholesterol at the same time. We either have high cholesterol or borderline high, but we can't be in both categories at once. I write too big. Sorry. You guys probably had it much more concise than me. You can't have high cholesterol and borderline high cholesterol at the same time. In plain language, what does event A or B mean? Somebody want to take a shot at that one? A or B? French fries or salad? A or B? High cholesterol. Sorry, go ahead.
You can have high cholesterol or borderline high cholesterol,
Yep. Thanks.
but not both.
You don't have to put the not both part. Just say you can have high cholesterol or borderline high. So A or B means, and I'm gonna put it into a little context. I'm gonna say the person, because it says we choose an adult at random. The person has high cholesterol or borderline high cholesterol. And then the last part of that question can kind of get lost. It does ask us to find what's the probability of A or B. And we know that when they're mutually exclusive, the probability of A or B is the probability of A plus the probability of B. So probability of A or B is the probability of A plus the probability of B, which the American Heart Association tells us A is 0.16 and B is 0.29, and that'd be 39.45. Excuse me. So the probability the person is has high cholesterol or borderline high cholesterol is 0.45. And then our last question, if C is the event that the person chosen has normal cholesterol, meaning they have below 200 milligrams per deciliter of blood, what is the probability of C? So this is where a Venn diagram might be helpful. I'm not saying that if you can do it without the Venn diagram that you have to do it, but as we get into harder and harder probability questions, it might be helpful. So we have our sample space. We have event A, they have high cholesterol. That happens with a probability of 0.16. Borderline high. And by the way, my circles will never be to scale. Never. Because see, my A is bigger than my B, sorry. That's 0.29. So this is high, this is borderline high. And then we're looking at event C, that it's normal or below 200. So that would be everything outside of A and B. So this is event C out here. Now C happens to be the complement of A or B, because it's everything that doesn't fall in our A or B picture. So the probability of C could also be referred to as the probability of A complement and B complement. So A not happening and B not happening. And remember, we have our complement rule. So we would do 1 minus A or B. And we just found the probability of A or B. So we would do 1 minus 0.45, which is 0.55. So the probability that the person chosen at random has normal cholesterol is 0.55. Do you guys have any questions for me?